So absolutely. So I think over the last few years since the discovery of MOE88 and CXR4 mutations, there's been a lot of work done in genomics and transcriptomic changes to characterize Waldenström's and IgM-MGUS, and also looking for potential clues that can tell us why some patients are progressing from one state to another. But that only looks at one part of the genome. It looks at the protein coding component of the genome, and you know there's a much larger part of it that's not protein coding, or the non-coding RNA. Somewhat is divided into size by micro or small non-coding RNA and long non-coding RNA. So the long non-coding RNA was the topic of our discussion yesterday, focusing at the large parts of RNA that are not coded into protein. So some of the insights we found that several non-coding RNAs, which you know they have a regulatory component or regulatory influence in some of the protein coding RNAs, have been found to be upregulated or downregulated in Waldenström's compared to IgM-MGUS. Interesting that some of those non-coding RNAs, the long non-coding RNAs, they are very near or very close proximity to oncogenes or potential oncogenes. I think the most important finding of the data was about PVT1. PVT1 is a long non-coding RNA known to have an oncogenic role, known to be associated with MYC, a non-oncogene, and potentiate MYC or causing MYC amplification and cause cell proliferation through different mechanisms. So I think that was the most interesting finding. One, PVT1 being overexpressed in Waldenström's compared to MGUS, but also several other long non-coding RNAs that are near oncogenes that we are yet to study and to better describe those.